So up until this point, we have looked at two things with respect to firms and their decision on how much to produce. We've looked at how we define profit, comparing the difference between accounting profit and economic profit and learning what a normal profit is. And we have also looked at how firms maximize their profits by producing at the quantity where the marginal revenue is equal to the marginal cost, which we called the profit maximizing rule. Next, we're going to look at something that we call the production function. And in doing so, we're answering this question. We want to know, how does a firm combine inputs? And think of what our inputs are. Land, which would be our natural resources or raw materials, labor, the work and effort used to put something together and produce a good or service, and the capital goods, tools, equipment, machinery that are used to produce it. And so how does a firm combine those inputs to get the output of goods and services they want? Well, they do it by the way of something we call a production function. Think of a production function like a cook with a recipe for soup. The cook adds varying quantities of ingredients. The cook would add labor, heat, and ingenuity to a fixed quantity of capital, such as a pot and a stove, and then the inputs would all be combined and a soupy output would be produced. So all goods and services, whether they're simple like soup or complex like Boeing 787 airplanes, have a production function. And that's what we're going to explore in this module. So in this module, first we're going to discuss the importance of the firm's production function, which is the relationship between the quantity of inputs, land, labor, and capital that are used to produce a particular quantity of output, goods and services. And we're going to explain why production is often subject to what we call diminishing returns to inputs. In other words, as we add more land, labor, or capital to a fixed input, we get less and less output in return. So we'll see why this is the case. And that's what we're going to explore in this module. So let's begin with this idea. First of all, what is production? Well, production can be defined simply as converting inputs into output. In other words, we have all this scarce land, labor, and capital, and as consumers, we want goods and services. So we take that land, labor, and capital, and through the production process, we turn them into the goods and services that we want. And those are the outputs. So that's a simple definition of production. Now, in class, we're going to be working on what we call a widget production simulation. So we're going to skip these points for right now. I'm going to skip over these slides, and we'll come back to those in class. But for this video, we'll look at the production function itself. And we'll define it this way, as I said before. A production function is the relationship between the quantity of inputs a firm uses and the quantity of output it produces. So we have two different types of inputs that firms are concerned with. There are inputs that are called fixed inputs. And a fixed input would be an input such as land, labor, and capital that cannot be increased in the near term to increase production. So even if we want to produce more, one of our inputs is fixed over a certain period of time, and we can't change its quantity. So we're stuck with that. And so we're limited to producing the quantity that we can produce with that fixed amount of input. Okay? And we'll define what that period of time is later in the module. Variable inputs are different, though. Variable inputs, something is variable, it means it can change. So a variable input is an input whose quantity the firm can vary at any time. So if it needs more raw materials, it can immediately get more raw materials. If it needs to hire more workers, it can immediately hire more workers, or decrease those inputs as it might need. So here's an example that we might talk about. Before we get to the example, let's talk about the difference between the long run and the short run. Economists and suppliers talk about the difference between the long run and the short run. And when they use these terms, what they mean is not a definite period of time. Oftentimes students, when they encounter these terms, think that, well, what is the short run? Is the short run defined as 2 hours? Is it 3 days? Is it 5 months? Is it a year, 2 years? And the answer is it depends. It's different for every firm. For some firms that produce simple products, the short run may be a very short period of time, like a matter of days or weeks. For more complicated firms, they may have a short run that spans several years. So it's not a defined period of time. The difference between the short run and the long run is the time in which at least one input of production must remain fixed in its quantity, meaning you can't change the quantity of that input in that period of time. Now, oftentimes this might be, well, let's say you want to expand production and you want to increase the size of your factory, or you want to open a new factory to produce. Well, it takes quite a while to add on to a factory or to build a new one, right? So over a certain period of time, you are limited into how much you can produce of your product by the size of the factory that you have. So that is defined as the short run. In the short run, at least one of your inputs is fixed in quantity and can't be changed, and so your production decision as a firm and how much you can produce is limited by that fixed input. You might be able to change the quantity of some of the other inputs, but at least one input remains fixed. But given enough time, you can change the quantity of all of your inputs. Given enough time, you can add on to that factory, or you could build a new one. You can hire many more workers. You can get many more raw materials. So the amount of time it takes to be able to change all of your inputs, any of the inputs that you want in terms of quantity, is what was called the long run. And over the long run, you can increase the quantity that you produce because you can increase all of your inputs. But in the short run, you're limited in how much you can produce by that fixed input. And so firms have what is called a total product curve. Okay? And the total product curve shows how the quantity of output depends on the quantity of the variable input for a given quantity of the fixed input. So this would be true over the short run, which is too brief a time period to alter our plant capacity. So the capital of plant size is fixed in the short run, but as I said, in the long run, the firm can change the quantities of all resources employed, including the capital plant size. So now let's focus on Max and Eli and their lemonade stand. And we'll assume that Eli and Max are running their lemonade stand, and to increase output, there are some variables they can easily change almost immediately. These variables are labor. They can hire more workers quickly. They can buy more lemons quickly, more sugar, more water, more cups, more ice. They can get and increase all of those very, very quickly. Okay? But there are inputs that, at least not very soon, cannot be increased to produce more lemonade. The lemonade stand itself, which is capital, is such a fixed input. So if the capital is fixed now, how much time must pass before they could expand it? Well, it kind of depends, and that illustrates the difference between the short run and the long run. In the short run, they can't change the capital, the lemonade stand, but in the long run, they can increase the size of the lemonade stand. So we will focus on the hiring of labor at the lemonade stand, a variable that we can change in the short run. And the table here shows the total production of lemonade at each quantity of labor hired. So if we hire one worker, that worker can produce 8 cups of lemonade. If we hire a second worker, together they can produce 18 cups of lemonade. If we hire a third worker, all 3 of those workers can produce 26 cups of lemonade in an hour. Okay? And so you can see from the chart how much lemonade we can get produced in an hour based on how many workers we hire. So now we can plot the output at all levels of hiring. So to just review this point, when we look at inputs and outputs, remember, to earn a profit, firms must make products, goods and services. That's their output. Inputs are the resources used to make those outputs, and they are also called factors, or factors of production. So when you see the abbreviation TP used, it's referring to total physical product, or the total output or quantity that we produce. Remember, marginal product is different. Marginal product means the additional output. Marginal always means additional, so it's the additional output generated by additional inputs. So if we add more workers, for each worker we add, how much more do they add to our total product? The additional output that they add to our total product is called the marginal product. So the marginal product is defined as the change in total product divided by the change in inputs. And then we have another term called average product, which is the output per unit of input. And to get that, we just take the total product and we divide it by the number of units of labor, the number of workers that we have. and that gives us the average product that each worker is producing. Now that's different than the marginal product, because marginal product is how much is added by each successive worker. But if we divide our total product by the number of workers, then we're getting the average product per worker. It doesn't mean each worker is adding that much to the total, but that's the average that they're producing. And these terms will be important as we move through the production function. I've talked about the difference between fixed and variable resources. Here's another example of that. Remember, fixed resources are resources that don't change with the quantity produced. So an example might, in the widget production simulation that we're going to do in class, might be the table that we use, the scissors that you have, and the stapler that you use, which don't change through the production process. But the variable resources can change, and then they do change with the quantity produced. So if we want to produce more, we have more workers, we get more paper, we use more staples. And so one thing you might want to do to see if you understand this is, try and identify 3 fixed resources that a pizza restaurant might have, and what are 3 variable resources that a pizza restaurant might have. And if you can identify 3 of each of those, you have a decent understanding of what the difference between fixed and variable resources are. So now going back to Max and Eli's lemonade stand, if we graph what was in that previous chart, we come up with something that we call the total product curve. And all we're doing here is looking at the number of units of labor that we hire, the number of workers that we hire, and how many total cups of lemonade do we produce based on the number of workers we hire. You can see that up until a certain point, at least until we hire the 6th worker, we are increasing the total number of cups of lemonade that Max and Eli can produce. But after the 6th worker, and notice if we hire a 7th worker, the total number of cups of lemonade we produce actually goes down. So we can see that this total product curve increases rapidly as the first 2 workers are hired, and this is due to specialization. Think of it like when you do group work, and you're in a group and you divide up the task. You're given a big task to do, and maybe you have 4 people in your group, and you say, okay, we're going to split up the work, and each person's going to do one piece of the work. You're specializing when you do that, instead of one person doing everything, which would take longer. If you divide up the work, you can finish the work more quickly because each person is doing one part of it. That's called specialization. And that's what happens in the beginning when we hire the first few workers. They specialize, and they perform tasks that are best suited to their talents. As the 3rd through 6th workers are hired, total product does continue to rise, but at a slower and slower rate. Because opportunities to specialize have been exhausted, and that darn lemonade stand isn't getting any bigger. It's still the same size. And by the time we hire the 7th worker, the lemonade stand is too crowded with people. The 7th worker actually begins to get in the way of the production process and causes total output to fall. So we can see that the additional contribution of the next worker by computing the marginal product of the variable input. The variable input in this case is labor. We're increasing the number of workers. Here, you can see the same thing happening with George and Martha's farm if they're producing wheat. Okay? And again, you can look at the table and compare it with the total product curve, and you can see that when we add the 2nd worker, they add 17 bushels of wheat to total production. But when we hire the 7th worker, they only add an additional 7 bushels. Their marginal product is much less because you have fewer opportunities to specialize, and they may be getting into each other's way at that point. So the total product curve rises fairly quickly in the beginning with a relatively steep slope, but then the slope flattens out, and it gets less as we add more and more workers as the marginal product begins to decline. So, defining the marginal product of labor, we define it as the change in the quantity of output divided by the change in the quantity of labor. Now, if we're increasing labor by 1 worker at a time, that denominator is just going to be 1. We're just dividing it by 1, so it would just be the change in the quantity of output. But if we're changing the quantity of labor in groups that are more than 1 at a time, then you would want to do that to get the marginal product per worker. So this is the formula that we use, and it's defined as the change in the quantity of output generated by 1 additional unit of labor. And so we use abbreviations for it. Marginal product of labor is abbreviated as MPL, so when you see that MPL stands for marginal product of labor, and that equals the change in quantity, delta Q, divided by the change in the quantity of labor, delta L. And that's the definition for it. So, if we go back to our graph, and we looked at the total product graph before, notice on the vertical axis we had total output and the horizontal axis was labor. And so the equation for the marginal product of labor is really the change in Y divided by the change in X, or the slope of the total product curve. So the slope of the total product curve is always equal to the marginal product of labor. So if you get that question, they say, well, what is the slope of the curve equal to? It's equal to the marginal product of labor. Or if they ask you the marginal product of labor, it's equal to the slope of the curve between those 2 points, because it's just the change in Y divided by the change in X, which is defined as the slope of the curve. So now we can plot the marginal product of labor in a new graph. The marginal product, you can see from this chart, declines as more labor is hired to a fixed amount of capital. Remember, the lemonade stand is the fixed input. We can't increase the size of the lemonade stand in the short run. So as we add more workers to that particular size lemonade stand, the additional number of cups of lemonade that each worker can add to the total declines as we add more and more workers. So what happens to marginal product then as we hire more workers, and why does this happen? Well, this is what we refer to as the law of diminishing marginal returns. As variable resources are added to fixed resources, and remember, in the short run we said at least one input is fixed, okay? And oftentimes this fixed input is a capital good, such as an oven, machinery, tools, because it takes a certain amount of time to increase our capital. Variable resources like raw materials and labor often tend to be easier to change very quickly. And so in the short run, we can increase those. But in the short run, as variable resources, such as workers, are added to fixed resources, the additional output produced from each additional variable resource, which is a worker in this case, will eventually fall. Now, we might say there are too many cooks in the kitchen, and they all stumble and get in each other's way. They're all trying to do too much, and it just doesn't work well. So notice that as you hire more workers, the additional links that each additional worker creates begin to decrease if we were to do a link production activity. And this is because of the fixed resources and the law of diminishing marginal returns. So, diminishing marginal product of any input is a defining characteristic of production functions in the short run. And this concept is really very simple. As you add more labor to a fixed quantity of capital, the next worker contributes less and less to the total than the workers who came before. And this is not the result of hiring inferior workers. They're assumed to be just as good as the workers that came before, but it's a result of having less space and not enough tools with which to work, and that prevents the sixth worker from contributing as much as the workers who came before. Now, suppose that once enough time has passed, Eli and Max are able to expand the size of the lemonade stand. The table that we have would be adjusted accordingly. And let me go back to the table that we see here. Not in the right place. This video right here, let me just mention this. This is one that you can go to on the ACDC Econ website and look at Mr. Clifford, and he'll give his explanation of diminishing marginal returns. So make sure that you take time to look at this video. And we'll work on the law of diminishing marginal returns worksheet in class, so you'll get some practice with it there. And this is the curve that I wanted to get to. We are now plotting the marginal product of labor in a new graph. And you can see that the marginal product declines as more labor is hired to a fixed amount of capital. It increases in the beginning because of specialization. That's why you see it increases slightly. But then it declines, and eventually it goes below zero and becomes negative as workers get in their way or they don't have enough tools to work with. And so, again, if we're looking at the farm, where we're looking at the number of bushels of wheat that are added per worker, you can see the marginal product of labor declines. So it is a downward sloping curve. The marginal product of labor curve is a downward sloping curve because there are diminishing returns to labor when you're adding them to a fixed input. In this case, it would be a fixed amount of land. Now, this gets back to what I was referring to before. Suppose that once enough time has passed, Eli and Max are able to expand the size of the lemonade stand and make it bigger. Well, we'd be able to produce more lemonade, and so we would adjust the table accordingly. And you can see here that when we look at the table, it's different. You know, we hire, for each worker we hire, they're producing twice as many cups of lemonade. So the marginal product of labor is actually bigger than it was previously. But notice, it increases slightly in the beginning, but it still declines, and it's still subject to the law of diminishing marginal returns. So even if output doubles, marginal product still declines. And even though the lemonade stand is larger, once additional workers are added, they will still eventually experience diminishing returns, even at a larger amount of output. And it would look like this on this particular graph. So if we look at George and Martha's farm producing bushels of wheat, you can see on graph A, looking at total product curves, in the first total product curve, when we hired 8 workers, we could produce 10 bushels of wheat. But maybe they double the size of their farm and they get 40 acres of land instead of 20 acres of land. Well, now with 8 workers, they can produce 20 bushels of wheat instead of 10. So yes, once you increase that fixed input, you can produce more total product. But that input will still remain fixed at that larger size for a given period of time and will still be subject to diminishing marginal returns. So your total goes up, but you still have diminishing marginal returns. And you can see in panel B that even though the product is higher, the marginal product of labor is higher at 20 units higher, it still is a downward sloping marginal product of labor curve. So you are producing more when you increase that size, but you're still subject to diminishing marginal returns at a higher level. And that will always be true over the short run. And this affects firms' production decisions. Now, back in the 18th century, there was an economist who is often referred to as the one that created economics as being sort of the dismal science, because back in the 18th century, when he wrote his book, An Essay of the Principle of Population, he introduced this concept of diminishing returns to an input. He was the one that discovered it. And at that time, the population of the United States was about 4 million people. And Malthus argued that as the country's population grew, but its land area remained fixed, it would become increasingly difficult to grow enough food to feed the population. And today we have 320 million Americans, so he predicted by now most of us would be starving and hungry. But over the long term, Malthus's predictions have turned out to be wrong. Why is that? Is it because he was wrong about the law of diminishing marginal returns? No. What he didn't anticipate was technological progress, that we've gotten more efficient at farming, that we've developed new farm equipment with newer technologies and new fertilizers that get greater yields per acre of land. So we can grow more food more efficiently on an acre of land. And he didn't see that change in technology. So change in technology, improvements in technology allows us to get more total product out of a fixed amount of resources. But we still have the law of diminishing marginal returns at work, or we'd be able to feed the entire world on 1 acre of land. So Malthus was still right. He just didn't anticipate the change in technology that would allow us to produce more. This activity here, production terms to know, we'll deal with in class. And so on this slide, we get to the summary of this Module 54. And again, you can pause the video now. You can review this summary, maybe copy it into your notes. But this concludes our look at Module 54 on the production function.